Alright, chemists, so let's have a look at the metal activity series and the periodic table. How do these two interact? So by the end of this, we want to be able to understand how metal activity series relates to trends in the periodic table, including ionization energy, atomic radius, and electronegativity. Basically, I want you, by the end of this, to be able to talk about, here is a trend in the periodic table, and this is why it is affected by the metal activity series. Or, more importantly, this is why its ease of oxidation, which is what the metal activity series is all about, affects this trend. So here's your vocab. Just pause the video now, write this down, and this way you've got it to refer back to as we continue on. So, the metal activity series. And this is it here, just off to the left of your screen. We can see lithium at the top. Sometimes potassium. Lithium's not always on this list. Potassium down to gold. Now, it's just the metals. It's not all the metals. And you'll see that the top, if we go up, we're talking about an increasing ease of oxidation. Over the left, we react vigorously with H2O to form hydrogen gas, then with steam, and then with simple acids to form hydrogen gas. And then down the bottom here, we've got some which will not dissolve in simple acids at room temperature. If we heat them up, we can make it happen. So metals are arranged according to their ability to oxidize. In other words, this means lose electrons and therefore form positive ions. So very active metals displace H atoms. Sometimes you'll see it saying hydrogen gas, but technically they're displacing a hydrogen atom, and they then bind together to form hydrogen gas, to form water to make hydrogen gas. So here's our potassium. When we put it in water, we find that we have these become an aqueous together. This is an ionic solution, an ionic equation we've written here. So we get 2 potassium ions for 2 hydroxide ions and a hydrogen gas. And you can see that the oxidation is occurring at the potassiums, which means the hydrogen gas here is also reduced, but the focus of this video is on the oxidation power of it. Less active metals displace hydrogen atoms from acid to produce hydrogen gas, but then we've got even less active acids that won't do that unless a significant amount of energy is put in there. But for example, here we have zinc, which is combined with hydrochloric acid to give us zinc ions, chloride ions, and hydrogen gas. And the zinc is that which is oxidized. So let's have a look at metal activation and ionization energy. Ionization energy is the energy required to remove the first electron. In other words, the energy required to oxidize an atom, because that's oxidation is loss, or loss of electrons, Leo the line, depending on which one you prefer. So metal activity is a measure of the ease of oxidation. So we can see that there is a link here, and down here we go from our lithium to our lithium plus, and that's an oxidized lithium atom. And here we can see that ionization energy increases as we move up and increases this way. So potassium or lithium, well, lithium's weird actually. We'll ignore lithium. Scratch that one out. That's why potassium is usually the one at the top. We see potassium here has quite a low ionization energy, and as we move up and over this way, we see the ionization energy increases, and they tend to move further down this list. So oxidation is loss of electrons, and therefore as a metal activity increases, the ionization energy decreases. Again, lithium's a bit weird in the fact that it does oxidize very easily, but its ionization energy is a bit higher than, say, sodium or potassium. So let's have a look at metal activity and electronegativity. So the electronegativity of an atom is the ability to draw a bonding pair of electrons in. Now, the metal activity series is organized in order of metals to oxidize or lose electrons, which is the opposite of drawing a bonding pair of electrons in. So, as metal activity increases in the periodic table, the electronegativity decreases. And we can see that, right? Like the metal activity tends to increase in this direction down here. It tends to increase with the opposite of ionization energy. So as metal activity increases, electronegativity decreases. Now let's have a look at metal activity and the atomic radius. Okay, so electrons, when they're further away from the center of the nucleus, they're easier to remove, right? Or from the very positive nucleus, and that's why they're easy to remove. As they get closer, the positive attraction is stronger and they stay there. Now, there we go. If the outermost electron is further away, oxidation is more likely to occur. Therefore, if the atomic radius increases, metal activity also increases. All right, I hope that made sense. If you have any questions, pop them in the comments below, and we'll get back to you as quick as we can. Hit subscribe, and you'll be able to keep up with everything we're doing. And yeah, thanks for watching, and we'll see you next time. Bye now.